Hey, how you doing? Tech here. A little bit of an electronics thing going on. We're going to talk about chips. And boy, what a ambiguous term the term chip is. You see the term chip, and that just means all kinds of things. That could mean like everything from an advanced processor that you'd find on an i9 that costs thousands and thousands of dollars to a little piece of potato flake that you pull out of a bag from some restaurant while you're eating your lunch. Chip gets used a lot within the electronics industry. It can mean anything from a small doodad to something that's got some higher functionality associated to it. It can actually mean quite a bit of stuff. The chip that I would like to show you, the one that we're going to be actually soldering up to our circuit board here in the spot on here, is called is this little guy, which I'm trying to show on the screen there with a little bit of a background there. Yeah, you see that? Kind of looks like a little bug. That's what it kind of looks like. And this bug, if I put it underneath the microscope right now, is this little guy. Now, let's go over to let's find a nice blank spot first to take a look at our chip, if you will. So there's our chip. Our chip is an 8-pin chip connector. Is what it is. What we would call a small outline package or an SOP device. Is what that's called. This particular chip has the term NE555. That's because this particular chip is a timer circuit. It is a 555 timer. One of my overall personal favorite chips that I've worked with in education for years and years and years. Its use in the industry is probably frequent, but it's one of those points to where it's like, it's probably there somewhere. We all like to think it is. I hope it is. Can someone tell me if it is? Just like, comment, and, tell me whether or not it's there. I've always thought that it is because this is one of like the top 10 most versatile chips that you could find in the engineering life. They do all kinds of things. Like the primary thing that it does is it outputs square waves based on other electronic components that are kind of soldered around it in its place to it. But this guy in particular, which is really not all that large when you're actually looking at this guy, and is made by, you can see the little Texas Instruments logo just barely in the center part of the pin. Now, a little bit of some chip terminology. Typically speaking, any kind of microchip, and that's like the kind of the bigger term. That might be where this term kind of comes from. Microchip is where that is usually something that has a higher degree of functionality. This 555 timer is actually marked with a bar on the top of it. This is what we would call a polarity indicator. Polarity means that it's an electronic terminology that basically means like one way. Like batteries are polarized. If you put the batteries in backwards, the thing don't work. If you put this thing in backwards, the thing don't work. Okay, so this little bar that's on there is usually indicated that this thing cannot be connected in one way, and there are 3 ways to be able to connect this chip component up to its rightful spot. Its actual spot here is the spot that has the silkscreen designation called U2. And U2, not associated with the band or anything like that, the U2 indication, why the term U? Interestingly enough, because you'll see U around there, these are called microchips. And if you were to look up in engineering lingo, the mathematic abbreviation for micro is 1/millionth, but most folks don't have time to be able to write down like 1/millionth or write down all the zeros associated with moving the decimal point over 6 points over to the left. So instead, what they do is they use the Greek letter mu as an abbreviation for the term micro. Mu kind of looks like a U with a wrong way, a U with the with an elongated beginning. So like imagine like drawing a P without the top. It's kind of the easiest way to phrase kind of what a mu is. It looks like a U, except at the it looks like a U. No, I'm doing it. Am I doing it the right way? A U. I'm trying to do it right for you folks that are on the screen. Except the beginning has a much longer. So it's like you go up, and then there's a U that goes over it. And then you go back down on there. Anyway, it's all Greek to me. Probably Greek to most people out there. You take engineering classes, you start to learn Greek. You can't say anything in the language, but you sure know a little bit of some mathematics behind what the symbols actually mean. Anyway, micro is the reason that has has a U in there is because the term microchip, micro is often abbreviated with Greek letter mu, and that just so happens to be the Greek letter for the word U. So the term U is on here for micro. Kind of a little thing if you hadn't guessed where I was going there already. If you already knew that, well, then you just, well, sorry for boring you for the last minute or so. Anyway, if you were to notice, this chip actually fits on these pads very, very nicely. You see that it kind of fits, if it's almost like it was made to do so. And if one were to take a closer look at the silk screen layer, there is not only is there a dot indicator that's up here, this indicates pin 1, is what this is. Most chips that I've encountered that have pins on the outside that you can see go starting from one pin and then counterclockwise, or for you British folks out there, anti-clockwise, whichever. But going counterclockwise around it, it goes 1, 2, 3, 4, 5, 6, 7, and 8, and then goes around in a circle like that. Anything with pins on the outside that's like pretty common. That's what I've seen. Not saying I've seen every single microchip out there, but in general, that's kind of what I've seen with it. If I were to look at the chip, there is a little bar that's on there, and when I place these two in their correct positions with one another, there is actually a bar that aligns up with the top part of it there. This is the correct way that the chip should go in. This would be the correct way that it would function normally. Now, if I were to take the chip and I were to give it a little flip-de-flu and put it around upside down, well, at this point right there, the chip is going to have what we engineers like to call a problem. And that problem is that there may be arcs and sparks and things that don't in general smell very good or make it very good for that chip to be able to do any sort of functioning, at least in the right way. So this is the wrong way to put it on there. This is the incorrect polarity if one were to pull one of those out of there. And then finally, the other incorrect way to put this down is this way. This way is kind of silly. I've actually seen a couple of projects where people have designed this a little bit incorrectly. This is the chip is upside down, or what I like to call dead bug. You know, see, you get it? Because it's live bug, because hey, it's moving towards you. Hey, it's a live bug, and then you flip it upside down. It's a dead bug. At that point, I've heard people in the industry call it that term as well. But anyway, this is another wrong way of doing it. But as you can plainly tell, this would be somewhat of a hard thing to do, because if one were to look at this thing at an angle, the pins on the chip would not be touching the pads at all. So this would be a hard thing to actually connect up if one were to do something along those lines with it there. That would actually be just a little bit of a problem there. But if one were to look at the chip, there is actually a little bit of some angularity associated with the chip in terms of how that is. If actually one were to look very, very carefully, one would notice also that there is a notch on the top part of the chip, on the top left side of the chip. You can see that some chips actually have that notch, which can help to determine what the polarity is, depending on what the machine or the person is that's looking at the polarity. We're talking about automated optical inspection is what we were talking about, which some companies do employ. But for us folks who don't have $5 million machines or anything like that, we're actually just going to put this down using the correct polarity. Now, in order to solder this guy down, we have to apply the following items here. The first thing that we're going to do is we're going to move our little bug chip off to the side. Here, you go over there, bug. Hey, how you doing? All right. And now the next thing that we're going to do is we are going to apply some fluxing agent to this here. So we're going to take some flux and come down across all of the pads here. There we go. So a couple of pads here, a couple of pads there. There we go. There we go. There we go. And the next thing that I'm going to do is I'm going to grab some solder off of my spool. There's some solder coming off of my spool here that I've got. And grab my large tip soldering iron. Now, I am going to tack down one of the pads of this chip. And I'm going to kind of zoom in a little bit so you can all see more or less focus on the pads of this chip. And those pads, by the way, those are we talked about other printed circuit board pads that you've seen before that are silver. These are actually gold. They are flashed over with a very, very thin coating of gold. Gold has a really cool property in that it doesn't really rust easily in a Terran atmospheric environment, a normal Terran atmospheric environment. I realize there's all kinds of environments that are out there, but typically speaking, in your average place, gold will not rust. So they flash it over with a very, very thin layer of gold in a process called electroless nickel immersion gold processing for this particular board, which makes it to where the board will actually last a little bit longer. Which is kind of a nice thing for if you have to store it in a potentially not so good condition. So I'm going to take my soldering iron, touch it to the pad, and then tin what I call tin just one of those pads on the board there. See that? Next thing I'm going to do is take my soldering iron, move it over to my left hand, and take a pair of tweezers in my right hand. And with surgical precision, I'm going to come down. I'm going to make contact with the small spot there, allowing it to melt. And I'm going to move the chip into its position here. And I'm going to take the soldering iron, make sure that it's there. I want to watch that solder essentially kind of creep up the side of the chip just a little bit, just enough to where I see it going into place. I don't want to stay there for too long, but I've got it basically aligned up at this point, which is kind of nice. I am later going to touch the chip with the with this. In fact, if I do so, one will notice that if I take the tip of my soldering iron and touch just the chip, it's oops, excuse me, that wasn't attached very well, now was it? Would you please come back here and join the family, so to speak? Here, hang on, here, you come back. Come back. Hey, how you doing? How you doing, pal? You want to come back into place? You want to come stay there? We got a nice house. Got a nice house for you to live in. How you like that, huh? Like that? Is that nice? No? That's not nice? That is not centered at all. That looks a little bit better in terms of what that is. So now at this point, the leg is soldered a little bit more into its place. What I'm going to do now is I'm actually going to tin all the rest of the legs of the chip, because now at this point, essentially, the chip is mounted into place. It's one pin is mounted, and all of the rest of the pins are all kind of pushed flush against the printed circuit board pads that we have. So now at this point, I'm going to come on in with my, oops, can you all see that okay? Can you all see that there? You all see that there? I'm going to do this kind of from a bottom down view. So I'm going to kind of rotate this guy a little bit of a 90 degrees and focus on the first the guy that's on the right. So I'm going to come here and apply a little bit there. That's a little bit too much is what that is, but that's okay. For learning purposes, that'll be okay. Here we go. A little bit down there as well. And I'm going to fix this guy. Notice, if you will, that the fluxing agent that I'm doing is helping to provide a better connection. That one on the right-hand side has got just a little bit too much associated with it there. Is what that is. We actually will probably talk a little bit later on how we remove that much solder to it there. Now the other side here. Where are you? Hello? Is that you? No? Yes? No? Ah, there you are. Hi. How you doing? How you doing, pal? Now we come on to the other side. Let me zoom in a little bit closer so you can actually kind of watch the wetting action, sort of the wetting action sort of occur for this here. Oops, I let go of the board. You there? Are you okay? Can you stay there in one place? Thank you. I don't have anything holding the board down to its place. So I'm going to touch this here. Now watch this as the solder just sort of creeps up both the side of the part as well as onto the overall pad itself. The solder is actually attracted to both the leg of the part on here as well. But you'll notice that as I continue to try and move this around, it's sort of, see that? Oh, you see that guy right there? You see that? That is bad. That is not what I want. You see this thing that's hanging loose? That's kind of probably hard to see. Let me kind of bring this back up and out for a second here. Okay, hang on one second. Where are you? Hello, Chip? Chip, is that you? Yeah, look at that. Ping! That's a that's a freaking problem is what that is right there. That is not something that you typically want associated with that. But under the conditions that solder is and the temperature of your iron, this can actually happen. The way that you actually get rid of this is you first apply a little bit of some fluxing agent to this here. So I'm going to apply, I'll try to do this at an angle here, a little bit of some fluxing agent. Then you take your soldering iron, waiting for it, of course, to get up to its temperature, where it is, and then hit the fluxing agent and then watch as that solder just all kind of falls back down and tries to form back over to the nearest solderable surface. Is what it actually sort of tries to do, which is kind of a neat thing the way it does that. So it's either one of those things that where if you are working with surface mount chip components like the way I am right now, this is all on the surface, flux is your friend. Fluxing agent is absolutely the secret sauce to overall how circuit boards tend to be processed. So now I'm going to move over to this side here, apply a little bit of some fluxing agent and solder over here, a little bit over there, and the final one that's on here. And overall, that's a good quality job, if I do say so myself. Take a look at this kind of from an angle here, and there you have it. Yeah, not too bad. Really well connected. Pretty sure that the one that's on here is probably going to look a little. That's oh, excuse me. I don't even know if you'll be able to see this. I was looking at it through my own scope there. That is a, boy. That is there's a lot underneath that one. The first ones that I was looking at were kind of on this side here, which I've got solder that's going up to the side of it. Again, not a perfect job. There's probably people who work in the industry that do this a heck of a lot better than I can, but I'm trying to give you kind of some insights as to how to be able to do this kind of from the start. Is where that is. So yeah, soldering a chip component U2, which is a 555 timer, down to a printed circuit board with gold Enipig pads is what it is. So or not Enipig, Enig pads. Enipig is for something entirely different, which we hope to be talking about at some point a little bit later on. So anyway, hopefully you got to see something new. Hey, if you're interested in hearing about some sort of a printed circuit board based thing, hey, let me know. I'd like to be able to kind of create a little bit of a something on there. I've got some materials of which to work on, but ultimately it's kind of up to what you all want to see. So put a comment down in the video below. Let me know if you learned something new with this here, and this is Sean Teg. We'll see you around next time. All right, see you later.